Hello and welcome to the Internet Journey presented by True Mind. One of the foundations of Internet is the information theory. The problem statement was how to transform a received signal, distorted by the physical medium, to reconstruct the original as accurately as possible. Claude Shannon in 1948 provided a firm theoretical underpinning to understand the trade-offs between signal-to-noise ratio, bandwidth, and error-free transformation in the presence of noise. Bell Labs developed the 101 modem, the first modem for computers. 1958. In late 1950s the mainframe computer model was devised, and modems, such as the Bell 101, allowed digital data to be transmitted over regular unconditioned telephone lines at low speeds. Christopher Strachey gave a paper time sharing in large fast computers at the UNESCO Information Processing Conference in Paris in 1959. The idea of time sharing as an alternative to batch processing emerged.
Before 1957, computers only worked on one task at a time. This is called batch processing. Of course, this was quite ineffective. With computers getting bigger and bigger, they had to be stored in special cooled rooms. But then the developers couldn't work directly on the computers anymore. Specialists had to be called in to connect them. Programming at that time meant a lot of manual work, and the indirect connection to the computers led to a lot of bugs, wasting time and fraying the developers' nerves. The year 1957 marked a big change. A remote connection had to be installed so that the developers could work directly on the computers. At the same time, the idea of time sharing came up. This is the first concept in computer technology to share the processing power of one computer with multiple users.
John McCarthy of Stanford University said, "By time sharing, I meant an operating system that permits each user of a computer to behave as though he were in sole control of a computer, not necessarily identical with the machine on which the operating system is running." 1973 to 1989 saw the era of merging the networks and creating the Internet.
On October 4th in 1957, during the Cold War, the first unmanned satellite Sputnik 1 was sent into orbit by the Soviet Union. The fear of a missile gap emerged. In order to secure America's lead in technology, the US founded the Defense Advanced Research Project Agency in February 1958. At that time, knowledge was only transferred by people. The DARPA planned a large-scale computer network in order to accelerate knowledge transfer and avoid the doubling up of already existing research. This network would become the ARPANET. Furthermore, 3 other concepts were to be developed, which are fundamental for the history of the Internet. The concept of a military network by the RAND Corporation in America. The commercial network of the National Physical Laboratory in England. And the scientific network cyclades in France. The scientific, military, and commercial approaches of these concepts are the foundations for our modern Internet.
Let's first talk about the networks that led to Internet. Robert Taylor, the head of the Information Processing Techniques Office, IPTO, at Advanced Research Projects Agency, ARPA, in 1966 had an idea that is, if you have these 3 terminals, there ought to be one terminal that goes anywhere you want to go where you have interactive computing. That idea is called the ARPANET.
Let's begin with the ARPANET, the most familiar of these networks. Its development began in 1966. Universities were generally quite cautious about sharing their computers. Therefore, small computers were put in front of the mainframe. This computer, the interface message processor, took over control of the network activities, while the mainframe was only in charge of the initialization of programs and data files. At the same time, the IMP also served as interface for the mainframe. Since only the IMPs were interconnected in a network, this was also called IMP subnet. For the first connections between the computers, the Network Working Group developed the Network Control Protocol. Later on, the NCP was replaced by the more efficient Transmission Control Protocol. The specific feature of the TCP is the verification of the file transfer.
At the National Physical Laboratory, NPL, in the United Kingdom, Davies designed and proposed a national commercial data network based on packet switching. Donald Davies was one of the inventors of packet switching computer networking. He coined the term packet, and today's Internet can be traced back directly to this origin.
Let's take a short detour to England. Since the NPL network was designed on a commercial basis, a lot of users and file transfer were expected. In order to avoid congestion of the lines, the sent files were divided into smaller packets, which were put together again at the receiver. Packet switching was born.
The Cyclades packet switching network was a French research network designed and directed by Louis Pouzin.
In 1962, American ferret aircraft discovered missiles in Cuba, which were able to reach the United States. This stoked fear of an atomic conflict. At that time, information systems had a centralized network architecture. To avoid breakdown during an attack, a decentralized network architecture had to be developed, which, in case of loss of a node, would still be operative. Communication still used to work through radio waves. That would have caused problems in case of an atomic attack. The ionosphere would be affected and the long-wave radio waves wouldn't work anymore. Therefore, they had to use direct waves, which, however, don't have a long range. A better solution was the model of a distributed network. Thus, long distances could be covered with a minimum of interference. Another milestone followed with the development of the French network cyclades. Since cyclades had a far smaller budget than arpanet, and thus also fewer nodes, the focus was laid on the communication with other networks. In this way, the term Internet was born. Moreover, cyclades' concept went further than ARPA's and the NPL's. During communication between sender and receiver, the computers were not to intervene anymore, but simply serve as a transfer node. Cyclades' protocol went through all machines using a physical layer that was implemented into the hardware, providing a direct connection with the receiver, an end-to-end structure.
Based on international research initiatives, packet switching network standards were developed by the International Telegraph and Telephone Consultative Committee in the form of X.
Inspired by the cyclades network and driven by the incompatibility between the networks, their connection gained in importance everywhere. The phone companies developed the X.25 protocol, which enabled communication through their servers, in exchange for a monthly basic charge, of course. DARPA's Transmission Control Protocol was to connect the computers through gateways. And the International Organization for Standardization designed the OSI reference model. The innovation of OSI was the attempt to standardize the network from its ends, and the channel's division into separate layers.
Finally, TCP/IP gave way to the standard protocol. With so many different networking methods seeking interconnection, a method was needed to unify all of them. A piece of software was installed on SatNet in 1982, and the ARPANET in January 1983. This resulted in a networking model that became known informally as TCP/IP. Defining Internet. The term Internet was reflected in the first RFC published on the TCP protocol, RFC 675, Internet Transmission Control Program, December 1974, as a short form of Internet working.
Finally, the TCP assimilated the preferences of the OSI reference model and gave way to the TCP/IP protocol, a standard which guaranteed compatibility between networks and finally merged them, creating the Internet. By February 28, 1990, the ARPANET hardware was removed, but the Internet was up and running.
1980s era saw the massive globalization of Internet. Opening the Internet and the fiber optic backbone to corporate and consumers increased demand for network capacity. In 1982, Norway, Norsa NDRE, and Peter Christian's research group at University College London, UCL, left the ARPANET and reconnected using TCP/IP over SATnet. The Computer Science Network, CSNET, began operation in 1981 to provide networking connections to institutions that could not connect directly to ARPANET. Its first international connection was to Israel in 1984. In January 1989, European Organization for Nuclear Research, CERN, opened its first external TCP/IP connections. 1980s Internet in Pacific regions. Japan, which had built the UUCP-based network JUNET in 1984, connected to CSNET, and later to NSFNet in 1989, which laid the spread of the Internet to Asia. Africa. In August 1995, Infomail Uganda, Limited, a privately held firm in Kampala, and NSN Network Services of Avon, Colorado, established Africa's first native TCP/IP high-speed satellite Internet services. Asia. Singapore developed TechNet in 1990. The invention of the World Wide Web by Tim Berners-Lee at CERN, as an application on the Internet, brought many social and commercial uses. The web opened to the public in 1991 and began to enter general use in 1993–94, when websites for everyday use started to become available. The Internet was widely used for mailing lists, emails, creating and distributing maps, e-commerce, online forums and bulletin boards, and personal websites and blogs. In 2000s, Web 2.0 has become the buzzword. This era saw several household names gain prominence through their community-oriented operation. For example, YouTube, Twitter, Facebook. The first Internet link into low Earth orbit was established on January 22, 2010. Stronaut T. Creamer posted the first unassisted update to his Twitter account from the International Space Station, marking the extension of the Internet into space. 2010 onwards saw mobile evolution. The 2010 mobile revolution saw smartphones move towards mainstream adoption, launches like the iPhone 4 and the growth of Android. Web 3 puts power back in users' hands through decentralized technologies. This fundamental shift in how the Internet works will transform our online experiences in several ways. With blockchain technology, you'll manage your information using secure digital tools. This shift means having complete control over your online identity and data. Internet of Things is the next future technology. Global Internet access. Satellite network will finally bridge the digital divide, bringing high-speed internet to remote and underserved areas. Low Earth orbit satellite constellations will provide consistent, high-speed coverage to virtually any location on Earth. Please subscribe to TrueMind channel and hit the bell icon.